When you think about businesses that are selling through the roof, like Skims or Allbirds, sure, you think about a great product, a cool brand, and great marketing. But an often overlooked secret is actually the businesses behind the business, making selling and for shoppers buying simple. For millions of businesses, that business is Shopify. It's home of Shop Pay, the #1 checkout in the world. You can use it to boost conversions up to 50%, meaning way less carts going abandoned and way more sales going through to checkout. Upgrade your business and get the same checkout Allbirds uses. Sign up for your $1 per month trial period at shopify.com/income, all lowercase. Go to shopify.com/income to upgrade your selling today. Shopify.com/income.
Does it ever feel like you're a marketing professional just speaking into the void? Well, with LinkedIn ads, you can know you're reaching the right decision makers. You can even target buyers by job title, industry, company, seniority, skills. Wait, did I say job title yet? Get started today and see how you can avoid the void and reach the right buyers with LinkedIn ads. We'll even give you a $100 credit on your next campaign. Get started at linkedin.com/results. Terms and conditions apply.
Hello, everybody. How are you? Welcome. Welcome to Somewhere on Earth, the Global Tech Podcast. I'm Anya Lichtarovic, and this week we are in Doha at Web Summit Qatar. It's Tuesday, the 25th of February, 2025, for those of you who want the metadata. And we are recording on the pitch stage in front of a live audience. Thank you, everybody, for coming today. Now, today, I'm really rather excited. I've met a fabulous woman, Sara Sabry. Welcome. Now, Sara, I'm going to say it. You are the only African Arab woman to go into space. You are the first ever Egyptian astronaut. Exciting. Welcome to Somewhere on Earth. You started your education, you became a mechanical engineer. Why mechanical engineering of all things?
Yeah, thank you so much. I'm really excited to be here, Anya. It's so great to meet you as well. Mechanical engineering, my passion for it came from just the idea of finding problems and like needing to solve them. So for me, it was never about a specific goal. If you would ask me when I was young what I wanted to be, I would just say I wanted to be an inventor because I couldn't really see myself in anything that was around me. And I felt like all I wanted to do was break toys and kind of put them together. I used to play pretend a lot, just dream about different worlds that had superpowers, had, worlds that were not there. And mechanical engineering were kind of like a tool for me to be able to not only understand the world around me, but also be able to solve the problems that existed there. So when you understand the machines that exist around you, when you understand the physics that is, just the base of our world, you can do so much with it too. And it kind of breaks a little bit that misconception or the idea that things are so hard because they've been built by another human being, so they can't be that difficult. And I think that idea for me is what led to, made me the person that I am. Mm-hmm. So mechanical engineering was just something that, for me, I thought was kind of like the Joker of engineering, where you get to learn all the little things about engineering and about the world. You just apply physics, apply what built our world into solving the problems that exist in our world. So I highly recommend mechanical engineering.
So were you one of those kids that had so much Lego or Meccano or, those kind of creator kits that you lose bits on and then your parents tread on them on the floor?
I didn't have Lego, unfortunately. I used to take my parents' remote and break it and put it. So I could use whatever was around me.
They must have loved you.
Yeah.
And then you went into biomedical engineering. Now, you've done some really fascinating research. You've done stem cell research, and you've also done AI in robotic-assisted surgery. Mm-hmm. Now, that sounds a little bit scary, but tell us what you did.
No, of course. So For me, when I was doing mechanical engineering, so I did my undergrad in Egypt. I did mechanical engineering focused, my concentration was in mechatronics, so it's kind of a mix between just designing machines, programming them, and also connecting the pieces together. So mechatronics give you just a very broad, just like a broad overview of how to build things from beginning to end. And then, and also automating them. So a huge part of mechatronics too is automating them. So when I finished that, I worked on, not what I finished it, but like throughout my mechanical engineering journey, I was really interested in cars, and that's actually one of the reasons why I started my mechanical engineering journey. And that's actually not something that a lot of people know about, but I'm a huge, huge fan of cars and motorsports. So I worked on a Formula 3 car. So I worked on designing it using biomimicry of a kingfisher bird. So if you look at the Shinkansen bullet train in Japan, it's the fastest train in the world, and we wanted to try to understand if we apply the same design that is also, the Shinkansen train is a biomimicry of a kingfisher bird, which a kingfisher bird is the bird that kind of just like goes and fishes in lakes or ponds or whatever it is, and catches fish and creates the least amount of has the least amount of drag and vibrations in the water. So that's why the kingfisher, the Shinkansen bullet train, when it goes into tunnels, it's not as loud as other trains. And if you apply the same thing for a lot of different factors, of course, like for downward force, for drag, for all of that, into a Formula 3 car, we wanted to understand that too. So I did that for a year, and that was really, really interesting. Was a difficult project, but it was really, really interesting, and I learned so much from that. And then I did minors in biology and chemistry because I was really interested in the human body as well. So I had an option of either going into med school or biomedical engineering, and I picked biomedical engineering just because I still love engineering, and I can't.
It's a little bit cooler, isn't it? I mean, that's where the really, really, really bright, cool kids go, isn't it? Because it is so much at the cutting edge, isn't it? That particular field of research. And what did you do there?
Yeah, I think it's exactly that. It's applied, like it's applying all of this into the medical field and into the human body. So it is very, very cool. And if you think about it, like it's so important. And so I worked I had my master's in biomedical engineering and then worked on stem cell research for neurodegenerative diseases. And again, it was about seeing this one problem.
And so that's things like dementia, Alzheimer's.
It's like MS, like
MS,
diseases.
Parkinson's, that kind of thing, yeah?
So it's a musculoskeletal disease. So it's incurable. But there are several treatments for it, and stem cells could be used for that. So what we were doing is, I worked in Berlin for a little bit in a stem cell research lab, specifically for that, where we were growing organoids in the lab. And
you were growing, run that past me again, you were growing what?
We were growing brain organoids in the lab. Okay. So it's the coolest thing to see, and I don't think a lot of us get to think about the stage that we're at in the biomedical fields. The biotechnology that we have right now is to be able to grow an organoid in a petri dish. An organoid means it's just basically kind of like a 3D of... So stem cells, we can take a step back. So stem cells are basically cells that are not programmed yet. And you can program them to become whatever you want them to become, depending on the environment that they're in, which also philosophically is really interesting if you think about it. But so what you do with stem cells is you extract them, and you can extract them from different parts of the body. So either embryonically or from your spine or different parts, and you can actually program them to become whatever you want. So you can grow a new ear from your own stem cells, or you can grow whatever. So I was working on the spine just because it was very relevant to my research, and the brain. So I was able to grow a mini brain in a petri dish. It was a very small one.
I love it. You know, who else but, you know, the first Egyptian astronaut grows their own brain, in effect, or someone's brain.
Small one. It's an organoid. So it's a mini. It's a very, very, very early stage. So it's not a developed organ. So that's why it's called an organoid. It's very, very early stage. So it takes a few months for it to grow and become something. But you see a stem cell go from just nothing, just a couple of cells, into something, and you see them attaching together, and you keep, I had to go every other day, even on one weekends, to change their mediums and really culture them. And it was one of the coolest experiences ever to be able to grow something like this. But throughout this journey, I missed this engineering part where I wasn't really building something. I was growing something in the lab, and it was so cool, and I learned so much from it, but I missed the mechanical side because at the end of the day, I'm still an engineer. It's in my blood. It's just what I do. So I ended up working in robotic surgery, which is very different from stem cells, but I finished my research in stem cells, so I completed that one, and I moved on to robotic surgery.
And so for robotic surgery, we kind of, it's not like a full robot, it's like a robot arm that's controlled by the surgeon.
Yeah.
But were you getting the AI to assist or the AI to control? Because that's new.
Yeah, no, that's a good question. So we have the Da Vinci robot now that exists. It actually operated on my sister a couple of years ago.
So tell us about the Da Vinci robot, because not everybody will know what it is. Tell us about it.
So the Da Vinci robot is basically just a few arms for a robot that the surgeon controls. And it's really, really, really... once we have better connectivity in different remote areas around the world, you can, in theory, operate on a patient on another part of the world with this Da Vinci robot. So if you think about it, because you have a surgeon controlling it. But right now, we're not, because of the lag of internet and all of that, we're not able to do that, but that's kind of the future. So if you think about it, you could do that also for space, which kind of started for me in that way.
I mean, you can do it for a different planet.
Yeah, exactly.
Wow.
If there's no lag. So like you can do it on the station, you could do it on the moon, but Mars has a 20-minute delay, so that won't be possible. But for me, what I did there was I wanted to see how we can increase autonomy for that. So the idea of having robotic arms on a patient, it increases precision, it reduces the likelihood of errors because it's so controlled. You have kind of like an area where you have the robotic arms inside the patient, and then the surgeon is on a different area controlling these robotic arms. But what if we can actually automate it? So that's kind of like the start of...
Well, wouldn't that be safer in some ways? Because you're taking out the human element and human error.
Exactly.
No matter how good the surgeon is, they can't repeat the same procedure or adapt it that brilliantly. So go on, tell us more.
Exactly. And then imagine having a surgeon that has all the experience, all the information in real time that exists in the world. Like, not surgeons can be just absolutely incredible, but they need a lot of experience to be able to do something. Imagine having an AI that has all this information integrated already and can learn in real time. So my part of this research was using logic reasoning to help automate it. So basically...
So go on, explain logic reasoning, because again, you're going, whoa, way over my head.
No, yeah, of course. So with machine learning, so what you know from AI is that it's basically like a black box. It uses a lot of data to be able to, design an algorithm that is able to use the data, extract the information that it wants, and then makes its own predictions and solutions, right? But you can't really see what it used to do that. So it can be manipulated. So I had a colleague who was working on manipulating it. And it can be so easily manipulated. So that's with machine learning. So you can take it a step further with convolutional neural networks and all of that, but one missing part is understanding the logic behind it. So what we were tasked to do, what I was tasked to do is when I was working with my supervisor, is he was working on the machine learning side. I was working on the logic reasoning side, which is basically creating those rules, the logic behind why the AI would make these decisions. So when you wanted to know why the surgeon was making these decisions or why the AI system was making decisions, you already know because those are the rules that you set. So I had to watch.
Because you have to put the right input into the AI,
Exactly.
don't you? And that is so vital. So you were working all of this out on the logic, yeah?
Yeah, so you had to, basically you program it. I used answer set programming, which honestly, you don't need to know that.
No. That's definitely, we don't want to know about it.
It's horrible, honestly. It's to be honest, horrible.
You should have got the AI to do it, shouldn't you?
It's horrible to program. It was such a struggle to program with ASP because there was only just a few papers from the 90s that existed and had to reach out to the authors of that paper. It's a whole story. This is okay. We don't have to get into that. But the results showed that you can really, the accuracy of my system ended up to be so high that I interviewed some surgeons from different parts of the world and they said they would use it. So, no, it was a really, really interesting project and it has so much potential. And honestly, with Gen AI now, it kind of removes this part because I worked on this before Gen AI really was something that was available for everyone. So with Gen AI, kind of just, you don't need logic reason anymore because, well, I mean...
Yeah, it's just getting faster and quicker and better. So, So you've done your biomedical. You're now studying for a PhD.
Yes.
So tell me about your PhD. North Dakota, is it?
Yes. I'm doing my PhD at the University of North Dakota in aerospace sciences. So moved from mechatronics to biomedical to now aerospace. So it's basically just kind of narrowing it down into that one application for spacesuits. So spacesuits are basically a small spacecraft that touches the human body. So that's why you need both types of backgrounds to be able to work on a project like this. So I worked at the NASA-funded lab at the University of North Dakota, and there we have projects that range from 3D printing spacesuits because, well, when you're, let's say, like if you're living on the moon or Mars, if something happens to your suit, you need to be able to
you can't nip home and get another one, can you?
Yeah.
Yeah, so you've got to be able to produce a new one, haven't you?
Exactly. So that's why NASA is so interested in this, and that's why it's funding this research, because you need to be able to produce parts, to be able to fix it. There's a lot of research in materials. Materials are so important, especially, let's say, in being resistant to damages or self-repairing materials. That's so interesting. To automating some sensors and really being able to, like what you're seeing in movies, basically. That's kind of like what I would love to, that I'm striving for. It's really just like this automation, which we're not there yet. But the automation side of spacesuits. So basically from monitoring the health of the astronaut while they're doing an extravehicular activity, an EVA, / spacewalk, or whatever you want to call it. And being able to tell them that depending on like their respiration rate, their heart rate, and their blood pressure and all of that, whether they should be doing X or Z or Y or whatever. So that's my current PhD research.
Why have we brought a science researcher on stage? Yeah, not only that, astronaut, mega researcher, studying for your PhD, you just happen to have your own company. Yes. And you've got some big news today. So tell us about what you're working on and tell us your big news.
Yes, of course. We just announced it today. So I'm very, very excited to share this with you here now. So my first company is called Deep Space Initiative, and that's not the new company, so that's not the announcement. I'm just going to give you a little bit of a brief there. So Deep Space Initiative, what it does is it's working on making space more accessible for everyone around the world, regardless of your opportunity, your passport, and all of that. Because for me, when I started getting into the space field, I saw how inaccessible it was. And even though I had like a technical background and I had everything, like I ticked all the boxes for job requirements that were available in the US because these opportunities don't exist where I come from. I could not apply legally because of my passport. So we talk about specific type of discrimination. I mean, I don't want to use that word, but like restriction, a type of restriction that we don't even realize exists, and it's just legal restriction that has been put in place since the Cold War, which needs updating right now. So we're working on that too. So
who do we write to? This is really serious,
Yeah.
That one thing that Somewhere on Earth really wants to do is talk about the untold, unloved tech stories and ensure that people have access to technology. So tell us what we can do to help.
I mean, that's what DSI was created for. Like, it's able to provide these opportunities and bypassing this a little bit.
So you're just saying, right, you do it your way, we're doing it our way.
Yeah. And we are a US-based nonprofit, so we do still have restrictions. But at the same time, we have a legal department, so we work with space lawyers to address that. It's a work in progress.
There are space lawyers?
Yeah.
I love this. I didn't know there were space lawyers.
Yeah, we have a team of space lawyers. I took some space law and policy courses for my PhD as well because I needed to be informed, because I do a lot of advocacy work. So part of my public speaking that I do in different events around the world, like the World Economic Forum or the UN General Assembly or COP or all of that, we have to speak to those policymakers and world leaders. And so I had to be informed of the actual legal side. So I did write a couple of articles on, let's say, for example, the militarization of space and how it's actually in contradiction with the UN laws that are there. So it's really funny because we always think that governments don't make. I mean, we know that they make mistakes, but we don't really think that they're doing something that's illegal or that's in contradiction with international law.
And they might be doing something illegal in space, you're saying.
Yeah, no, I mean, at the essence of it, if you really look at the technically behind the law, the militarization of space or the creation of the Space Force in the U.S., technically it's illegal. But we don't really think about it because, someone else did it and we have to do it first because if we don't do it, they're going to attack. Well, that's not really how it works, Like, if you have international law, if you have specific rules that are there, then follow them. You can't just go out and say, I'm going to protect freedom. I'm talking about the U.S. here, also. I want to protect freedom by doing something. So where's the line here? Where is the line that you cross by saying that you want to protect freedom and protect rights by breaking them first yourself? So where's the line? How do we, where's that's a question mark and there's no actual solution there. But I digress. So
just for our listeners who will be listening online, just to say we haven't got new theme music. That's the Web Summit theme music. Okay, that's their radio jingle. So that's what you're hearing at the moment. But go on, Karen. So this new company that you've got is called Strive.
Yes.
And tell me what you're doing. And you've also got a few kind of tricks up your sleeve as well, haven't you, with it? So go on.
Yes. So Deep Space Initiative is the first company. So today we're announcing Strive. So it's a space and terrestrial research for innovative ventures and exploration. So what is Strive? Strive is at the intersection between space tech and Earth sustainability. So whenever you think about space, you think it's in contradiction with Earth sustainability, right? Why are we going to space and investing in space and really solving problems for space and forgetting about Earth? Are we going there to escape and are we just kind of abandoning Earth? That's not really it. You use space tech every single day in your lives. There's a lot of technology that has been produced for space that can be applied to solve some of the challenges we have here on Earth. And this ranges, So what we do at Strive is we organize these missions in different parts of the world in some of the most remote locations.
And where's your first mission? Tell us.
Our first mission is going to be in the Arctic. So we're going to be spending 2 weeks in the Arctic in this August, conducting different types of experiments. We're going to be working with different startups from all over the world, really testing their technology and working with the communities on the ground to help integrate that there. So one example is building solar panels for them and then helping the communities that are there because it's so different. It's such a unique climate and it's such an extreme environment but there are people living there still. So we need to be helping them out there. We need to be able to monitor the different changes that are happening in the environment. So there's always this monitoring side and detection, and there's the treatment side. So Strive aims to do both. And and we're here and we're open to partnerships. We just announced it today, so it's still, you're the first to hear about this.
Very excited. Thank you for sharing it with us here at Web Summit and with our listeners who are downloading around the world. You can't really talk about what you're going to be doing yet in detail because obviously you've got to have your own trade secrets. But you're going to be working in very remote places. You mentioned underwater volcanoes, but you're going to be going to remote places where there are communities, where there are people living. How are you going to marry the two? You're going to have some special projects, are you?
Yes. So we have one specific person. So Strive. We're basically 3 partners. So myself, who's handling most of the tech side of things, and then you have my partner Benjamin Potier. So he has a PhD in anthropology. He's a space artist. He's gone on 7 analog missions. He's worked on Arctic research before, and he. As an artist, what he wants to do is also be impactful in the way we storytell this. So we want to be loud on the activism side, but in a beautiful artistic way. So what we do is basically really push the message out there that it's important that we do have changes here on Earth. We can't really ignore them. We can't just be sitting here on the sidelines and ignore the fact that there are changes in this environment. And what we want to do, too, is for governments and agencies that are saying they want to help and they want to do something, well, this is your way to do it. And we're there, and we're actually implementing it. We're on the ground implementing these things, and you can collect the data, too. So it's all about data. And we have a third person who, because we know that these locations have people in them and they're affected by these climates as well, is that we're going to integrate them into where she's going to be designing curriculums to integrate them in these communities and teach them how to use this tech Or so it starts with understanding what the issues that they're facing first, and then creating these curriculums.
So again, it's space tech, because you're designing stuff to take with you to explore intergalactically, but that can also be used here on Earth.
Exactly.
Have you got any examples? Can you tell us anything?
Definitely. I think, let's say for water infrastructure. So where there's a lot of investment in ECLS, so environmental control and life support systems for space stations or habitats. But we kind of never really think about how we use them on Earth in these remote locations. So maybe in one of the communities that we're working at or with, they need better water infrastructure. It could be either in the recycling side or the management side or the detection side. So we help them integrate it there too. So that could be one thing, like for infrastructure in terms of the environment, so for life support, basically. So that's one side. Another could be with producing, so for agriculture. So we have a lot of progress. We've made a lot of progress, and there's a lot of investment in that too, in being able to grow plants for space. So you create these, so there's a lot of progress there. But we need to be able to also help out in different areas and communities.
So I'd assume that would be really helpful in arid environments.
Where, sorry?
So if you're growing in space, you're not going to have much water, are you? So it will work in desert country, won't it?
Yeah, exactly. And you can automate stuff. You can automate the whole process. So there's a company too, a good friend of mine, she's the CEO and founder of this company. What they do is they build these biopods. They automate the whole process. And you can leverage that. So they have a space, applications, and they have Earth applications. So you have always both. Whenever we think about space, we're always thinking it's just that, but it's always both. You can always apply that to here and there. So that's why we want to do. That's what Strive is here for. It takes this and applies it for both.
That is very, very exciting. So underwater volcanoes. Tell me a bit more about those.
Yeah, so I can't really announce what our next year's mission is going to be, just because I'm not really allowed yet.
Okay. So lots of contracts signed that you can't talk about.
Yeah.
But you're going to. That's certainly an area that you're going to be looking into as well.
Yeah. So it's the different climates around Earth. Really, they range from. So the first one is polar. So that one is the one that I can really talk about the most.
Arctic,
and then
that you're doing
volcanoes, and then you have so volcanoes because it's so similar to environments on Mars, and the polar, the Arctic mission too. It's an analog environment to Mars too. And then you have underwater missions. So and it works for both too, because you work on training for EVAs, so extravehicular activities, because you have to wear pressurized suits. You have to. One of the ways that astronauts train is underwater, because it's really relevant to how you conduct spacewalks. So it's both for that. So you can test spacesuits, you can test all of this technology, but it also work on, let's say, reef restoration. You work on tracking the acidity of the water. You work on, so it's so many. Like I don't think I can even say all of them here, but like every climate is very unique and it's very relevant to both Earth and space. And I think it's we need to be able to highlight this synergy more, and that's what Strive is here for. Is to really be at this intersection and show the world in a very poetic and artistic way, because that matters so much in the way that we see the world. And like it's activism, and it's tech, and it's communities, it's everything.
Now, my final question to you. We're running out of time, but I haven't actually asked you, what was it like in space? Tell us about your mission itself. It was Blue Origin, yeah?
Mm-hmm. So about 2 years ago, I got selected to go to space. I had been training for about 1.5 years before applying to this program, and it's called the Citizen Astronaut Program. So it's the first of its kind. It's the only one that exists that selects astronauts that's not government-based. Usually when you think of astronauts, you think the government has to select them, and that's true. But because I'm from Egypt, I'm not allowed to apply to any of the programs that exist. NASA, JAXA, ESA, any of them. So this is the only one that I could apply to. And I applied, and I got selected out of 4,000 applicants from all over the world. And they only select one person. And I went to space 2 weeks later, so I only had 2 weeks after the selection. And the selection process was long.
And that was enough for training, yeah? You were ready to go.
Yeah, I had been training for a year and a half, so it was okay. But for this specific... So then I was told that I was going to fly on Blue Origin, so you never really know which provider you're going on with. So I flew on Blue Origin. You don't really need that much training for a Blue Origin flight because it's a short flight and it's sub-orbital. But because for me, like, that was my career and I wanted to go. And I still want to be able to spend more time in space and do the research that I'm doing there too, especially on another planetary surface. But yeah, I flew to space on Blue Origin and it was life-changing. Seeing Earth from space breaks your reality. It's a lot more profound than you think it would be. I got selected as a scientist and engineer to analyze something called the overview effect, which is what happens to your brain when you see Earth from space. And if you think about it, because we haven't evolved as human beings to see this, it breaks your reality.
Now, I'm going to stop you there because we're running out of time. And if you subscribe to Somewhere on Earth, you'll be able to hear more about that because I'm going to try and chat to you later. Somewhere on Earth is a proud partner of Evergreen Podcasts. A huge shout out to the guys, the backstage crew who've done the audio. Thank you very much, Web Summit Qatar.
Hi, everyone. It's Michael Calore, Director of Consumer Tech and Culture at Wired, here with my colleagues, senior writer Lauren Good.
Hello.
And Wired contributor Zoe Schiffer.
Hey, everyone.
We're here to tell you about our new podcast, Uncanny Valley, a show about the people, power, and influence of Silicon Valley.
Every week, we get together to talk about how technology and culture from the Valley is influencing our everyday lives.
We dig into questions like, will we ever get our privacy back? Is OpenAI for real? And how are Silicon Valley billionaires impacting U.S. elections?
The first episode of Uncanny Valley comes out on October 31st. Listen wherever you get your podcasts.